have f of x equals 2x to the power of 4. This is our original function. When we differentiate it, we get f dashed x. So remember, what we do is we take this power, we bring it down and we times it by that 2. That's going to give us 8. Our x stays exactly where it is. That 4 then decreases to 3. So if we differentiate 2x to the power of 4, we get 8x cubed. Same with the next one. If we start off with f of x, we then change to f dashed x, which is our derived function. Our power moves down and multiplies by our coefficient here, so 9 times 5 gives us 45. Our x stays exactly where it is, and that 5 then decreases to 4. So our final answer would be 45x to the power of 4. Now, if we move on to this next example, we are changing to y equals. So this is where your derivative notation would change. So if we start off with the function y equals, it would then end up as what we would call dy by dx. Remember, f of x and y are the same thing. They both represent a function. Make sure you're being careful with your notation and always make sure you're using the correct notation. So we have to use dy by dx at this point. Now, comparing this example to the previous examples, you can see that there's more terms in this one. However, you just work through your terms individually and make sure you're using your rule for each part. So, if we've got 3x cubed, the power 3 moves down and multiplies by the coefficient 3. That gives us 9. X stays where it is, and our power of 3 decreases to 2. So that's us done with this first part. We can then move on. So we've got 2. 2 is going to come down and multiply by, remember at this point we've got a secret 1. So it's going to become plus 2, x stays where it is, and we decrease that 2 down to 1. Obviously we don't always write that power 1, same as we don't always write that coefficient 1. So that's just going to be 2x. Right, this next part I want to talk a little bit more about. So looking at this part here. So if you have a function f of x equals, say, 3x, okay, that x, remember, has got a power of 1. So if we were going to differentiate this 1 would come down and it would multiply by the 3. The x to the power of 1, that 1 would decrease to 0. Now remember that anything to the power of 0 is just 1. So essentially what we're saying here is that we've got 3 times by 1. So keep in mind that this part here is our differentiated function, and it's just going to give us 3. So we started off with 3x. When we differentiated it, we ended up with 3. So if we started off with, say, f of x equals 7x, when we differentiate that, you would work through the same steps, but we don't always have to do that. The rule that we need to know is if we've just got an x with a power of 1, we're just left with our coefficient, so we're just left with our 7. So if I move back over to this example here and just look at this minus x part, that, remember, is x to the power of 1, and there's a secret 1 here. So when I take this 1 down and multiply by 1, I'm left with negative 1, and our x would become x to the power of 0, which would just leave us with 1. Okay, so again, if you have a function such as f of x equals 9x, when you differentiate that, you would just be left with 9. Okay, so with an x to the power of 1, it disappears and leaves you with your coefficient. Now if we look at this final part here, so looking at this plus 7. So think about that plus 7. That is just 7. X to the power of 0, but obviously we don't write that because remember we've seen over here that x to the power of 0 would just give us 1, which would again just give us our 7. If we were to differentiate this, that 0 would move down and multiply by our 7. Anything times by 0 just gives us 0. And we would have x decrease that 0 to minus 1, which just means 0 times by x to the power of negative 1. Again, anything times by 0 just gives us 0. So again, if we had something like f of x equals 15, x to the power of 0, just 15, when we differentiated that, we would just end up with 0. So what we need to remember is that if you've got a number term on its own where the x to the power of 0 isn't shown, you just end up with 0, it disappears, okay? So if you've got a number and an x on its own, you're left with just a number. If you've got a number on its own, it disappears. So this here would be your final answer for this question. So 9x squared plus 2x minus 1. Moving on to our final example. So again, we're starting off with a function y, which means that our derivative is dy by dx. This time I've got a negative power, but you still follow the same rule. So this negative 2 comes down and multiplies your 6, which gives us negative 12x. Be careful with your negative powers. Remember, if you decrease, you're getting further away from 0 in your negative. So that's going to become power negative 3. Okay, so that would be your final answer. However, I do want to point out at this point, think back to National 5, you wouldn't leave anything with that negative power. So you will get your marks for that, depending on the type of question that you're asked. However, you'll see that as we progress through this topic, there are occasions where you will have to simplify that. So to simplify that into a final answer, that x to the power negative 3 has to move down to your denominator and become x cubed on the bottom. So that would also be accepted, and there are occasions where that would be necessary, but I'll point that out as we're going through the topic.